Hey guys, we finished up chapter 1 and now we're going to move into chapter 2. This is chapter 2, section 1, and today we'll be discussing the distance formula. In math, a lot of times when we're doing modeling problems, we're going to want to be able to measure the distance between 2 points, particularly in word problems where we're talking about physical processes. Something like maybe you have 2 people traveling in different directions, both riding bikes, and after an hour you're curious how far apart they are. That's a question that we can answer using the distance formula. So for our first example, we're going to discuss how to find the distance between 2 points, and particularly the 2 points 3, 5 and 5, 7. So first we'll just draw a picture, a little grid. Put some tick marks there for the x-axis and tick marks for the y-axis. Go a little bit higher because we need 7. So our first point, let's change colors and do it in green, is 3, 5. So that's over 3 and then up 5. 1, 2, 3. And then our next point is 5, 7. So we move to the right 5 and then up 7. So we have these 2 points and we want to find the distance between them. So the distance of this line segment that I just drew. The trick is actually going to be derived from drawing a triangle. So we can dot in a triangle. And this is not just a regular triangle, it's actually a right triangle. We know that we moved in the x direction, we moved from 3 to 5. And in the y direction, we moved from 5 to 7. So that's going to tell us that one side leg has length 2 and the other leg also has length 2. And then we recall our favorite theorem, the Pythagorean Theorem. And that will actually tell us the exact distance from our first point to our second point. Because that distance, let's call that distance x, then x equals the square root of 2 squared plus 2 squared, which is the same thing as the square root of 8, or 2 root 2, depending on how you like to write it. Both answers would be fine. And if we're looking at any 2 points, let's say we're looking at points x1, y1 and points x2, y2, then you can draw a graph again with 2 points and dot in a triangle. And we get back the formula that the distance will be the square root of x2 minus x1 squared plus y2 minus y1 squared, square root. And this would be a good point in the video to pause and think about why or how this formula is the same formula that we used right above. And with this formula, it's then very quick to find the distance between any two points. If we look, we'll start to write distance as this function d of -1, -2, 3, 4. So the distance between the points -1, -2, and 3, 4. And we're just going to plug right into the formula. So -1 is our x1, -2 is our y1, 3 is our x2, and 4 is our y2. And so we just plug those numbers in. That gives us 3 minus plus 1 squared. Because the -1 and the minus sign combine to make a +1. Plus then 4 plus 2 squared, which is the square root of 16 plus 36, which is square root of 52. And I think we can pull a 4 out of there, so that way we get it to actually be a 2 root 13 as our final answer. Another way that we can phrase our questions or to find the length is maybe instead phrasing it as finding the length of a line segment stretching between two different points. And so again, if we have a graph, and this time we have the point -3, 2, right there, and then the point 5, 3, maybe over there, then really the length of this line segment, it is just the distance between those 2 points. So again, we're just going to plug into our distance formula and see what we get. Start with the square root of x2, which is 5 in this case, and x1, which is -3. And then y2, which is 3 minus 2 squared. So that'll give us the square root of 65. And I think that's as simple as you can make it for right now. And that is a little bit bigger than 8. Since 8 squared is 64. All right, thanks for learning about the distance formula with me.